Hi guys, so we're going to be going over derivatives for this Calc Olympiad video. So this is really good review if you're in A, B, or BC for your AP exam, and this is also just really important for you to prepare for the Calculus Olympiad competition, so make sure you guys just watch through this entire video. Okay, so here's the agenda. These are all of the topics following like derivatives that will be on the Calculus Olympiad exam, and if you're in BC, all of these topics will also be on the AP exam. So this is just really good review if you want to study for both of these things coming up. Okay, question of the day. What is a derivative? So the derivative is the instantaneous rate of change for like a given variable, right? And you could also say it's like the slope of the tangent line. So here's the definition of a derivative. Just make sure you guys commit this formula to memory. This will be on your AP exam, and it's also probably going to show up on the Calculus Olympiad exam. So yeah, make sure you write this down and commit it to memory. And then, yeah, like I said earlier, the derivative is the slope of the tangent line. So if this is like your f of x function, this line right here is your derivative. Okay, so here are some derivative rules. You want to make sure you commit all of these to memory. Everyone should have these rules committed to memory, like chain rule, quotient rule, product rule. But also remember your trigonometric functions and like your derivatives for those. So like you should know these, but if you've forgotten like your cotangent, secant, cosecant, just make sure you remember these. And then here's some of your derivative rules for elementary functions. So that would be like your power rule or your exponential rule and logarithmic rule. So make sure you guys remember that as well. Okay, so some practice. Pause this video and try doing these problems on your own, and I'll show you guys the solutions. Okay, so here are the solutions. Okay, so implicit differentiation. Make sure you guys refresh your memory on this. It's like when you're deriving both x's and y's, and we're going to be going over how to do this. So you guys need to remember how to do this. Okay, so pause this video and try doing this on your own, and I'll explain how to do this. Okay, so this is the original equation. So the first thing we're going to do is we're going to do product rule. So we're going to take the first times the derivative of the second. That would be 1. But since this is a y, you're going to derive with respect to x. Okay, plus the second times the derivative of the first, so 2xy. And then plus, now you're going to product rule this one, 2xy. And this is also with respect to x plus equals 3. Okay, now we're gonna put all of the dy's on one side, so like all the dy dx's on one side. And then you're gonna get sorry guys if this is kind of sloppy, but this is your final answer. So yeah. Okay, that's the solution. Okay, so here are the derivative rules for inverse trig functions. Make sure you guys write this down and also memorize these. This will definitely pop up on the individual Calc Olympiad portion. It probably won't show up on the team portion though. Okay, yeah, and then also refresh your memory on related rates, inverse trig functions, derivatives of inverse trig functions, derivatives of inverse functions. This is the inverse function. Okay, and then linear approximations. This is the formula for a linear approximation. Okay, so now we're going to be solving this Calc Olympiad problem. So this is directly off of the Calc Olympiad individual tests from the George Mason website. So let me write down the original equation. Okay, so we're given x equals 0. So what I'm going to do is I'm going to plug in x equals 0 into f of x to find f of 0. And this is going to give me our value for y. So that's just going to be 1, negative 1 squared, which is 1. So when f of x is 0, or f of 0 equals 1. So now I'm going to find the derivative of f of x. So I'm going to find f prime of x, and you're going to use chain rule. But the first thing I'm going to do is I'm going to find the quotient rule of this. So it would be derivative of the outside. So okay. Then I'm going to multiply that by low d high minus high d low all over low. Okay, and when you plug in 0, you're gonna get, it's gonna be 1, negative 1, so that's negative 1, and then negative 1 minus 1 over 1. That's gonna equal 2 times negative 1, negative 2, and you're gonna get positive 4. So f prime of 0 equals 4. Okay, and it's asking us for the equation of the tangent line. So we're going to plug that into the y equals mx plus b format. So we know that the slope, so since the derivative is the slope of the tangent line, we're going to take this value right here, f prime of 0, and that's going to be our m. So it's going to be y equals 4x, and then our b right here is our point f of 0, which is 1. So the equation for the tangent line is y equals 4x plus 1. Okay, so now we're going to move on to the next question. Okay, so for this question, we want to show that the derivative of this function right here is equal to 2 over x times the square root of 1 minus x to the 4th. Okay, so the first thing we're going to do is we know that the ln of x, like the derivative of ln of x is 1 over x, right? So I'm first going to find the derivative, or I'm first going to simplify this inside right here, because this function is like very long, and you can easily simplify this by multiplying it by the conjugate and just like simplifying it out. So it's a really long process, but I'll just go over the steps to do it. Okay. So this top part is going to become squared because it's 2 of them. And then the bottom part is going to become 1 plus, oh, sorry. This right here should be a negative because we're multiplying both by the negative. That should become this. Okay. So now we're going to simplify this. We're going to distribute this top part, and this is going to be very long. So, okay, these ones are going to cancel out, and you're going to get, because x squared plus x squared is 2x squared, right? So this first part, you can cancel out the square roots because you're multiplying it by the same thing. So that's going to become 1 plus x squared. Then this part will become negative 2 squared plus, okay, and then 2x squared. Now I'm going to simplify the top again. So that can become 2, and then these cancel out, minus, when you distribute that, it's going to become 1 minus x to the 4th squared, and then you can take out these 2's, you get 1 minus 1. Okay, so this is just the simplified inside of the function. And since we know it's ln of x, it's going to be 1 over this entire thing. So 1 over, right? And you can rewrite that as x squared over 1 minus square root 1. And you're going to multiply this by the derivative. So now we're going to find the derivative of this. That's going to be low d high. So 1 over 2 times negative 4x cubed times 1 minus x fourth. This is to the negative 1/2. And then minus the top times the derivative of the bottom all over bottom squared. Okay, so this is what it looks like simplified, and I'm going to further simplify this. So, okay, so when you simplify this out, you're going to get this equation right here. And you can take out an x from this right here. So I put in this chain rule part again. Okay, and that is going to simplify to 2 over x 1 minus x to the 4th. And so yeah, we just proved that the entire derivative is equal to this number right here. Okay, so now we're going to be going over this question. So we're going to use implicit derivatives to solve this. So the question is, find y prime of 0 given that e to the y plus e to the y plus xy equals e. So the first thing I'm going to do is, this equation right here is our original equation, right? And we're given that x equals 0. So I'm going to plug in x equals 0 into this equation. And I'm going to get, so e to the what power equals e? Y has to equal 1, right? And so from this, we know that when x is 0, y is equal to 1. Okay, so now what I'm going to do is I'm going to find the derivative of this function right here. So we're going to derive this with respect to x, and because of that, we're going to use implicit derivatives. So we're going to get ey times dy dx, because we're deriving with respect to x, plus x dy dx plus y equals 0. And we're going to put all of the dy dx's on one side to solve for dy dx. And we're going to get negative y over this. And since we know that y equals 1, we're going to plug in y equals 1. So we're basically doing this. Dy dx at y equals 1 equals negative 1 over e. And so here's our solution. So y prime of 0 equals negative 1 over e. Okay. We're going to be going over the very last question now. So for f of x equals ln 1 plus x over x for all x is greater than 0, we want to show that f of x is strictly decreasing on the given interval, and then we also want to show that f of x is less than 1 and greater than 0. So the first thing I'm going to do is I'm going to find f prime of x, and we're going to use the quotient rule. So now we're going to plug in 0. We're going to get 0 over 0. And because of that, you have to use L'Hopital. Okay, so those are the derivatives. Now we're going to plug in 0. So let me simplify this first. That's going to be x, negative x, and yeah, that's just negative x. And then the bottom is going to be no, I'm going to So yeah, we're going to take the limit. I'm going to simplify this really quick. It's going to be like negative x over and like plus this as well. Yeah, I'm just going to put dot 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 because when you solve the limit, your top part's going to be negative x, and we know that, or yeah, it's going to be a negative x, and then if you plug in 0, it's negative 0. So we know that the top is decreasing, and because of that, since this limit right here is decreasing, we know that f prime of x is less than 0 for all x greater than 0 because it has this negative x right here. Okay, and that helps us answer our first part of the question, the one that says show that f of x is strictly decreasing for all 0 to infinity. Because f prime of x is less than 0 for all values of x within this range right here, we know that f of x is decreasing for all x is greater than 0. Okay, so that's part A. Okay, so now for part B, we're going to do a limit here. So we're going to do limit as x approaches 0 from the right of ln of this over x. So when we plug in 0, this is a L'Hopital. There's 0 on top, 0 on the bottom. So we have to take the derivative, and this is going to be 1, and then x plus. Okay, so that's 1 over 1, and so that's 1. So we know that the limit of this equation is equal to 1. Okay, and so from part A, since we know that f of x is always since we know that f of x is always decreasing for all positive values of x, and since we know that the limit as f of x approaches 1 or 0 is equal to 1, we know that f of x is less than 1, but f of x is greater than 0. And that's how we can prove this part.